Well, good evening. My name is James Steinbach, and I want to welcome you tonight to Front Range Front End. We are a front end developer meetup in Denver, Colorado, but right now, since we're not meeting in person, we are everywhere. We're really excited to have a lot of folks joining us from around the web, where getting to Denver as individuals would be a lot tougher. I'm going to double check some audio here. So pardon my quick pause. And yeah, we're really glad you've made it out to join us tonight. We are still waiting in terms of changing how we meet, waiting for input from our host company. They are going to open things up whenever they're comfortable for in-person meetings. Sorry, good. Just confirm the audio is working. About a minute-long delay. So yeah, they're still working out their opening procedures, and we're waiting to hear back from them. But for now, we've still got YouTube. We've still got the live streams. We're still collecting more great speakers. This gives us an opportunity to have folks who aren't just Denver-based jump in and prepare a talk. And as Jason has mentioned in the chat, Jason Spiller, if you haven't met him yet, is one of our co-organizers. Really grateful for his help, his work with the meetup. But we are looking for people to present and give presentations. If you go to frontrangefrontend.com, there is a section there where you can find a link to a Google form and send us your ideas. If there's a topic you want to hear about but aren't comfortable giving the talk, you're totally welcome to request a topic. There's a form for that too. But if you are, getting ready for a conference coming up and want to practice a talk you're giving there, or just kind of getting your feet wet with conference speaking, dev relations, some of the more public teaching, educational parts of web development, we'd love to help springboard you. So by all means, hop over to frontrangefrontend.com and let us know what you'd like to talk about. Tonight we are talking about web performance. It is a 101 level talk. I don't consider myself to be a web performance expert. I have a very varied, I nailed that one, web development career history, working in everything from WordPress and Laravel over on the PHP side to React and Ember and Stencil and Vue on the JavaScript side, and static site generators like Jekyll and 11D and others. And so I've learned things about performance in the course of that career that apply no matter what your tech stack is. And that's what I want to focus on tonight. Performance techniques and tips and advice that works for you no matter what tech stack you have. I want to set some expectations here. Tonight you're going to leave here not as a web performance expert, sorry. It takes a long time to get there. But I want you to be able to understand the lingo. I want you to have a handle on what are the words and phrases and metrics and things like that that folks use when they're talking about web performance. Additionally, I want you to have a short list of good resources to refer back to. You can probably see a link at the bottom of the slide deck. I will get this link posted in Meetup later this evening as well, and we'll comment on the YouTube video of that link as well. The slide deck is a live web page, and I love HTML slides because they let me put links everywhere and send you out to more resources that go into much more depth than we're doing in tonight's overview. And then thirdly, I want you to be able to feel comfortable setting and accomplishing research goals for your own use cases. I've got a lot of experience optimizing WordPress performance, but I'm not going to talk about how to do X, Y, and Z in WordPress tonight. Currently working in React, spent a couple years in Ember before this, but I'm not going to talk about how to do A, B, or C techniques in Ember or in Vue or in WordPress. I'm going to talk about the broad things, the broad topics, and let you be motivated and search out the implementation techniques that you need for your specific tech stack. There are a few places where I'm going to recommend something that, an NPM module or a Webpack tool, because those are more common and those show up in a lot of build processes. But for the most part, I'm just going to kind of cover high level stuff. We're going to do the bird's eye view and look at the tops of all the trees and not, get down and actually try to optimize one specific tree. So I want to start off by covering what is web performance. We're going to define it. when you think of web performance, what do you think of? I had a friend who years ago, his job title was web performance artist, and he liked the performance artist side of things, and kind of like to say it in a way that you were wondering if he was going to start dancing or singing or performing something for the theater. It's not that kind of performance. For the websites and the web apps that we build to be performant, it means that they work well, and particularly that they work quickly. The first rule of thumb in web performance is make it fast. That's kind of the goal that everybody thinks of immediately with regard to web performance. How can we make it fast? How can we make the files smaller? How can we use fewer of them? How can we manage our requests? How can we compress things? How can we make this fast? And the reason we want it fast is not because fast on its own is some kind of cool goal, but because fast correlates into something users need. When we improve web performance and make things fast, we also make them more frictionless. Users don't want to wait. There's an awesome developer named Harry Roberts who has a consultancy doing web performance, and he has great talks where he goes through the actual uh, milliseconds to money metrics for some of his customers, where the more they wait on certain things to load on the page, the more people abandon the shopping cart, the more people bounce out of whatever flow you're trying to funnel a user through to help them accomplish the tasks they have, or that you're providing for them to do through your web app or your site. So we're removing friction. We're making it easier for users to do what they want to do with our sites and our apps when we focus on performance. And third, I like to get this into every talk. I always feel bad if I do a web development talk and don't make it at least a little bit about accessibility once in a while. When we're making things quicker, that removes friction so that more people can use them. But more than that, when we make the websites and web apps we build faster, we make them more accessible. And I kind of want to push aside the kind of shallow or entry level understanding that accessibility is all about making screen readers say all the right things to users who are listening to them. And that's definitely part of it. And like 80 to 90% of the blog posts you find about accessibility focus on how do you make sure things are communicated correctly in NVDA or JAWS or VoiceOver or an assistive technology like that. But it's not just about screen readers. If people can't access our sites, that's an accessibility problem. And big, complicated JavaScript bundles, I'm going to point on one performance issue in particular. Big file sizes always, but especially big, chunky JavaScript bundles are a real barrier to access. And here's what I'm talking about. If you're building stuff for people around the world, there are huge numbers of global or worldwide users who are showing up on maybe a 10-year-old device with an 8-year-old outdated operating system. Maybe it's an entire community of families sharing a single hotspot or a limited amount of monthly data for them all to use to access the web. Bruce Lawson has an awesome talk pointing out that www does not stand for the sad, unfortunate, maybe default assumption of some developers, wealthy Western web. It's not that at all. We shouldn't assume that every user has some kind of retina display or a high bandwidth connection or a device that's at least 3 years new. Huge portions of the world don't. And if we're building apps and sites for people across the world to use, then we're creating accessibility barriers when we rely on giant JavaScript bundles that sometimes overtax the processors on the device even. Many times chew up way too much of a family or a community's bandwidth or data for a month. So we make things more accessible to more people when we focus and spend our time thinking on performance and web optimization. As we go, I am going to pause for some questions near the end of each of these sections coming up. We are going to cover techniques specific to JavaScript, images, fonts, style sheets, and a little bit of HTML and server, but not a ton. The whole server thing is not tonight's scope. We're a front range front end meetup. And so I'll let a backend team do server administration talks about performance with you later. Maybe not on our channel, but hopefully those are the folks you listen to there. But I'm going to pause. There's about a minute delay in terms of what I'm saying here live in my house and what you're seeing there on YouTube. So if you have questions, like as you have them, just go ahead and throw them into the chat. And I'll pause at the end of each of these sections to cover any questions you have specific to that question or that section. So these are what we're going to cover. And we're going to make sure we know what we're measuring first. If we just jumped into all the optimization techniques and never thought about how to measure performance, I knew somebody years ago who used to always say, you can't expect what you don't inspect. If you're not tracking and measuring actual performance statistics, then all your optimization techniques are effectively they're impossible to quantify. We got to measure them so we actually know what impact we're making. And so that we know when changes to our code base increase load times or file sizes. So here are some of the older metrics you'll find. If you're reading web performance articles that are, let's say, older than 2 or 3 years, you'll find a lot of talk about total bytes. That's easy to calculate. What are all the files that are going to be served in the page? And how many bytes do they all take up? Multiply bytes by user's bandwidth. I mean, not literally multiply, but combine those two, and you get page load time. And then Google did some work and took a whole bunch of metrics related to load time and bytes and file size and some other details, and made one giant magic number by doing some weighted averaging and combining all those individual numbers. And speed index kind of serves as, if you only have one number to measure, go for speed index. It's probably a safe, easy one to go with. And then there's overall render time, even after the entire resource set has been loaded. But there's a newer set of web metrics that have recently come to town. These are called Core Web Vitals by Google, which is the main company popularizing them. And incidentally, every auditing tool you use that gives you these data points is running its audits against a Chromium-based browser. That's where these metrics are available. First, meaningful or contentful paint is like something is showing up on the page that tells the user they're not still waiting on an empty screen. Maybe just your navigation loads first. That's your first contentful paint, even if the rest of the stuff below it is still coming. Largest contentful paint is when everything on the page loads and is ready for a user to interact with it. Cumulative web or cumulative layout shift is a fun one. This is not so much about measuring a timing, how long it takes something to load, but measuring the effect of things loading or rendering more slowly. For example, if you're lazy loading images, or you've got JavaScript that file that loads and after the page is ready, make some changes. You might have a font file that loads after a couple seconds of delay, a connection is bad, or a CDN is a little buggy, what have you. Sometimes that causes stuff to move around on the page, and when that happens, it's very frustrating. Imagine this scenario. You've got a user, and in the sidebar, they're looking at their shopping cart, and at the bottom of that narrow column, after they show all the items they're about to buy, are 2 buttons. One is empty cart, and then there's one that says begin checkout. Let's say a user is getting ready to click on begin checkout when one of the images above in the product images loads just a couple seconds late. It loads and it causes a layout shift because the image is a different format, and so it's taller than the CSS expected, and it pushes those buttons down about 30 pixels. All of a sudden, you who are halfway through that click event almost to click go to checkout have clicked empty my cart. And as a user, you're intensely frustrated. Hopefully there's at least some kind of pop-up that says, are you sure you want to do this on a destructive action? That's a design concern. But yeah, cumulative layout shift is really frustrating to users. When people tap the thing they don't intend to, that's a good way to make your users kind of grumpy about your site. So don't do that. And to measure these statistics, these metric points, here are some tools I recommend. Web page test is great. We're going to look at screenshots in a second. Lighthouse only does a Lighthouse test. Web page test does its own test and Lighthouse testing. And then if you're using Webpack, here's a bonus. Webpack Bundle Analyzer is really useful, and let me show you how these all work. So here's web page test. You can see right across the top, there is the letter grades. My security score is kind of orangish red there on this particular site. If you can't control your server, like you're hosting on Netlify or GitHub Pages or something like that, it's outside of your control. The security score isn't really a performance metric, truly, but you can see the summaries for other major details they put here, image sizes, transfer sizes. This table here gives you some performance results, and it's got some of the newer ones mixed with some of the other ones. Time to first byte, start of render, first contentful paint. Here's speed index, that magic number that Google gives us. Some web vitals, document complete, fully loaded, and just goes through all of these. And then there's a whole bunch of tabs at the top of this report, and they give you more details about each individual thing you're looking at. Lighthouse tests look a little different on the other side. Here's what a lighthouse test looks like. Across the top are 5 short scores. You can tell I'm on the performance one where this particular site only has a 98%, only 98%. It could be higher, but 98 is not terrible. But then there's some advice underneath it in the diagnostics section telling me what I can do to improve. And that's a nice thing about Lighthouse is it's pretty good with tangible or actionable recommendations. And then finally, if you're using Webpack, you can install Webpack Bundle Analyzer. You don't have to run this in your, I guess, part of your development environment. This is a thing you can run as an analysis step, just like as before or after you build, whenever you want to. And what it does is it gives you like a data visualization of everything that's in your bundle file. So there's a big block of everything it's pulling in from node modules, and then there are some big chunks of what's happening. MobX for state management up there in the upper right, React DOM right in the middle, Material UI at the top left, taking up a bunch of space. And I was surprised when I saw this. This is a website I built as a hiring interview step a year ago. How bad React color lib in the bottom center. It's one component that I imported for a color picking browser input for a form. And little did I know that that one input is like, 75% the size of all the Material UI components I'm using combined, and almost as big as all of React DOM. So yeah, if I were going to use this for actionable information, I would say, hey, React color is a pretty big import, it looks like. I'm going to see if there's anything in there I can do to replace that with a lighter library or do some other optimizations. And I'm going to stop talking now because I'm going to come back to these topics in a second. But these are just an overview of a handful of tools you can use to get statistics and to get actual data about your tools. Lighthouse and web page test can be run from a node module. So you can include them in like a GitHub action or a CI/CD step with Jenkins or a similar continuous deployment tool like that. JavaScript performance, kind of our first big topic. How do we make our JavaScript files better and faster? We can do some things to fix the bundle size. I'm going to talk about uglification and minification in just a second. Tree shaking is getting rid of unused code. I think that label first came from the roll-up bundling library, and then Webpack adopted that practice as well. And then we're going to talk about how to choose packages so that we don't have a bloated or too large bundle. Uglification is taking working JavaScript and replacing long variable names with like short abbreviations so that the file size overall is lighter. We don't care if it says A, B, C as our function names or our variable names in the production code. As long as we have readable names in our source code, let the compiler do any uglification it wants to make names shorter. And as long as you're not attaching global stuff to the window, this is all super easy to automate. Minification doesn't change those names. It does remove all sorts of white space though. And here's a minification would look like. There are gulp tools for uglification and minification. They run inside of Webpack for the bundling processes as well. Generally, you won't get uglification on a dev build, something that's running locally for your local dev environment on your own personal laptop, your computer, your browser. But for production builds, you will want uglification and minification to just shrink every byte out of that file they can. All right, tree shaking. This is a fun one. It's a way to remove unneeded imports. And for tree shaking to work well, there's something we don't have control over, and that is the library developers, the library authors have to write their libraries in a way that supports tree shaking. Here's a pattern that you see sometimes. The first block is somebody will just import underscore from Lodash or the Lodash or something like that. And then they'll use like underscore dot sorted unique by or underscore dot flatten deep or underscore dot some other function from the Lodash library. However, if all we need to use is sorted unique by, we should use the structuring in our import and just import the function we actually need. And in that way, we're kind of doing a little bit of the tree shaking ahead of time and making it much simpler for our automated processes like build steps to handle that. Otherwise, we're importing the entire Lodash library. That's what the first thing does, and saving it to the variable underscore. And then you use dot to access any of its functions. And the second one You only import the function you need and use that. And last way to keep your packages smaller is to make good choices about which packages you install in the first place. Every JavaScript developer who wants to format dates in the browser reaches for Moment. Well, maybe not everyone, but it is by far the most popular thing and the thing that a lot of people reach for by default. Minified and gzipped, which are some compression techniques, Moment library is 72 kilobytes. It's big. That's like 2.5 jQueries. Unminified is close to 300K. Date functions does all the same things, some different, what do you call them, APIs, different method names, but is written in a tree shakeable way. Moment is not tree shakeable. It's all one big thing no matter what you want or don't want. Moment's library authors have not written it in a way that can be tree shaken. They've got a page about that on their own site, and they explain why they don't think anybody should fork it and try to make a tree shakeable version either. They've kind of, I think, end-of-lifed themselves that way from a performance point of view. They still got a ton of momentum, pun intended, so they'll be around for a while. Moment isn't disappearing. But date functions is written in a way that you can import just the functions you need, certain kinds of formatting, certain kinds of measurements related to time and dates, and only import the pieces you want, and it's really cleanly tree shakeable. And even before you tree shake it, it's only 20K minified and gzipped. I was looking at bundle phobia, a handy tool. You can plug in the name of the thing you're going to import, and it finds something comparable that you can use instead that maybe is smaller. Bundle phobia also pointed out one called day.js that's less than 3 kilobytes minified and gzipped and has the same API as Moment. So yeah, if you've been using Moment for everything, here's some great options to swap it out with. The package choices you make can directly impact your total bundle size. And like I showed you Webpack Bundle Analyzer earlier, that's a great tool to find out which of your libraries are taking up the most space in your bundle. We can also optimize our JavaScript with how we handle requests. I've got 2 attributes you can put on a script tag. If you mark a script tag as async, it will not interrupt the page render. It will go ahead and continue its load process and not block rendering. Otherwise, the JavaScript file will block rendering until it's, the resource is resolved and downloaded. Defer is even more aggressive and says, don't even bother trying to load this file until after the page is done loading, which is a handy way to do things like, you're going to load the page and then you're going to add some user-focused interaction that maybe is way down at the bottom of the page. Maybe there's a call to action that's at the bottom of a blog post and it's going to take the user a minute to get there. Great, you can defer any JavaScript that applies to only that part of the page until the page is done loading. I want to talk about bundling and some techniques there. If you're working on a single page web app, regardless of your framework, Vue, Angular, React, Ember, etc., you're going to get one big bundle, one big file, and that's all your JavaScript for the whole web app. That's kind of the default behavior. And that bundle can get really, really big. And where you run into problems with that is if different routes or different sections of your web app have really unique, particularly really heavy code. For example, maybe you've got an app that a bunch of users log into, they do all the user-based things, yada, 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 it's all great. You've also got an admin dashboard area too. And not only does it have a slightly different UI, so some different work with some styling and some components being imported, it also does a lot of data visualization and as such brings in a relatively heavy chart graphing JavaScript library. Don't penalize all your normal users who will never see a chart, who will never see a graph. Don't make that part of one giant mono bundle that everybody has to download. Instead, use code splitting to put all of that dashboard code that's unique to the dashboard in its own bundle. And then the code that's shared or just for all the users can be the default bundle. And there are some different splitting techniques depending on how your build process is set up and which framework you're using. I like Vue's technique. Their router has a neat syntax where as you're assigning like a page component, a Vue component to a route, you can give it a named split or chunk, and it'll automatically put all those named chunks together. And it makes route splitting pretty easily. Modular loading, I'm just going to kind of point us down the road. This is a future thing. It's based on browsers having support for the module JavaScript type, not just a standard JavaScript file. Modular types are formatted differently and have some different syntaxes that not all browsers support. Most modern browsers support it well, so this is pretty close to now future stuff, but still probably not what most teams need for a production environment. Tools like Snowpack get you modular loading, and what essentially they do is, to explain it very badly, but hopefully with a decent analogy, it's like they load all those things you are going to import, all those libraries, as individual JavaScript files into the browser, and the client side handles all the import statements, rather than a bundler and like Babel compiler, transpiler, handling all the import to one bundle stuff on its own. With modular loading, you can load all those different libraries, modules, NPM modules as it were, and let the browser handle all the import connections. So there are some tools, like I mentioned, Snowpack, that lets you start trying and testing that out and seeing how well that would work for your tools. But that's a thing that's probably, I'm not going to say probably, but maybe not production safe, depending on your browser support rubrics. And then the JavaScript you actually write, the code itself can affect how it performs in a browser. And this is not affecting your download speed time, but rather affecting the memory of the browser. And this is kind of like advanced JavaScript, and we should do some talks about this in the future. But some techniques here would involve avoiding memory leaks, add event listener if it's not removed when necessary, can leave a bunch of things in the browser memory that just choke it up. Too many global variables, not scoped locally. Scope everything as locally as it's necessary, as a rule of thumb. But we've all experienced a thing where, you know, Chrome or Firefox says, "Hey, this web page is not responding. Do you want to kill it or wait?" I mean, do we have to kill it? Can we find a less violent word there, browser UI teams? But yeah, that's what happens. And that's probably the result of memory leaks or JavaScript that's written in a way that it just chews up the browser memory and doesn't behave performantly actually in the browser. So that's been JavaScript. I'm gonna slow down for about a minute here before we move into images so that any chat questions can show up here at my end, but giving it about a minute or so. And if I don't see anybody adding questions, I will go ahead and move on. And of course, don't worry, if you write your question now and I don't see it before I move on to images, I'll come back at the end and cycle through and make sure I don't miss anything. Images are the next big thing to make less big. Again, pun intended. JavaScript is probably the biggest bang for your buck. Images are the next best thing, or in some sites, maybe the best thing. Depends on your build tool and your tech stack. So the first thing to do with images is compress them. And this seems like, oh yeah, good first step. Definitely is. That's if you're doing nothing else, at least compress your images. These are some tools. ImageOptim and SVGO have GUIs, graphic interfaces, for desktop and for the web. And all three of these tools are available as NPM modules that you can install on in a build process and have them run automated things. You can use gulp image min if that's doing your work for you, that kind of thing. And image min can run the SVGO plugin itself so that it can handle all of your files, raster and SVG. So yeah, depending on what tools you need, you can research these. Those are all live links so you can find out exactly what's going on. And as much as you can optimize, great. If you're doing, like I remember when I started web development back in the dinosaur days, not quite, but you know, I did a lot of work over FTP. And if I could run a local server, fix all the files and drag the folder into FTP and hope nobody visited the site while the transfers are taking place, that was the olden days. We didn't have automated deploys of Netlify and GitHub Pages and Jenkins and all those fun tools, Heroku. But if nothing else, if you don't have any other way you can automate it, but downloading the ImageOptim app and dragging the folder of images in there every time to let them get compressed before you commit them or upload them, that's the best you can do. Great, make a tiny step. My point here is to get you to take little steps and work there rather than like do all 19 steps and have a fully fledged massive build tool on the first try. So a little bit of progress is better than none. But yeah, these are images and we should compress them. You should also serve your images from a CDN if that's available to you, if that's part of the tooling your team is willing to invest in. There are lots of different CDNs. CDN is a content delivery network. It is a series of servers that are usually located around the world, and I'll respond to the same URLs so that a user anywhere can download a copy of any of your assets that's close to them, low latency, and probably much faster than you just having all these assets in your DigitalOcean server or wherever you're hosting things, HostGator or what have you. But beyond just a normal CDN where you can store all your static assets, images, style sheets, font files, even like JavaScript. I did a ton of WordPress work for a while, and every WordPress site has jQuery, right? We get jQuery right from a CDN, not usually from our own file storage. But image-specific CDNs are what I want to talk about for a minute. With an image-specific content delivery network, you can upload one original, giant, uncompressed, as big as you want to. It doesn't matter. It's okay. File for an image. And then the image CDN has URL patterns you can follow to request that image at any size, any compression level, even changing the file format, all on the fly. And we're going to look at how that works in a few minutes and a slide that has some code. But until then, this is cool. I want to show you a few other things so that we can get to kind of a combining several tactics slide near the end. Choose the right format. Don't use an image format that's heavier than it needs to be. And I'm not going to talk too much about this slide other than to say Jason Spiller, co-coordinator here, did a talk on image formats about a year ago, if I remember correctly. That's on our YouTube channel in our video list. You can go watch that. He does a great job explaining which format to use and where with a lot more detail that I'm kind of skipping past in this slide. We should be aware of WebP and AVIF. This is kind of like the next-gen image formats with even better compression algorithms that work download even quicker in modern browsers. You might wonder, okay, well, how could I use a modern image format like WebP or AVIF and still take care of my old image users? I need a bunch of JavaScript? No, not really. With a picture tag in HTML, it's part of the newer responsive image spec that's been around for 3 years now. You can have a source that points toward an AVIF file with the type as image/AVIF. And now browsers that can handle that are going to choose that file, and they're not going to go to the image tag, which is kind of serving as a fallback here. But an older browser that can't handle AVIF and has no idea what that type attribute means is going to skip that source element and go right to the image tag, and that's where it's going to find the source that it will download and display. So format switching is not terribly complicated. It all happens right there in your HTML. Responsively sizing your images is a great performance win too. We can't just like take the 2,000 pixel or 4,000 pixel wide giant image and say, well, it might be a giant iMac with a Retina display that's effectively serving 3,000, 4,000 pixels for a web page width. No, with this, we can use a source set attribute on an image or a source tag to give the browser a series of image URLs, image paths, and let the browser make a good choice about which one to use in what context. If you just do source set with like image sizes every 500 pixels, if you need that, great, that's a good win already. You can also add the sizes attribute to this tag, where you're essentially using a media query-like syntax to tell the browser, given the conditions of this media query, here's how wide the image will be displayed. And then otherwise, here's our fallback 2000. And then again, our source is the fallback attribute for browsers that can't handle source set and sizes yet. And this lets the browser choose which file to download, and it does like its own little brainy algorithm thing. And we don't like hyper specify it. It's a little bit like CSS. We're publishing a bunch of guidelines to the website for how things should be rendered. But the browser does a bunch of work with its own awareness of its pixel density, its current screen size, the rendered size of the image, and it does its best to pick the right file based on like not getting too big or too small or too far from any one thing. Lazy loading is also a neat attribute you can use. The loading attribute can have a value of lazy. If you've got images that are farther down a page, you want to apply lazy loading so that the user doesn't have to wait for all those images to load while the page continues to like compete to load the hero image, for example. Images that are above a fold, I like the air quote fold because there is no fold, there are folds, depending on all the devices that show up at your site. There is no single fold. But things that happen at the top of the page that the user is going to interact with quickly should not be lazy loaded. Those can get priority, and anything further down the page is a better candidate for lazy loading so that you don't, again, have those resources, those images competing with something up in the hero or the header. And now let's put it all together. And this is a slide I promised earlier where we take a bunch of techniques that we've talked about and we glue them all together in some sample code that hopefully makes things look pretty clear for you. We're back to our picture element wrapping everything. We start with a source that's going to get the AVIF version of our file. And what's happened in this, CDN.com is an imaginary domain I made up. It's actually probably a real domain that goes somewhere, so don't click on it unless you're curious and want to go there. I have no idea what it is. But anyway, CDN.com acts like Cloudinary. So what we did in this scenario is we uploaded trees.jpg at like 5,000 pixels wide. We just took the high resolution awesome thing that the designer got from the, the stock photo site and just uploaded the original. Awesome sauce. It's there on cdn.com and it's available. You can see down about the 8th line there for the source attribute. That's kind of our end of the day fallback. But by switching the file format, the file extension to AVIF, like you see in line 4 here, the CDN automatically generates an AVIF version of the JPEG, and it does the conversion for us. We don't have to automate anything. We don't need a build tool running, or we don't need anything happening in our commits or our deploy process. The CDN does it for us. It's amazing. Then in our image source set, we're going to use some resized versions, a 2000 pixel wide version and a 500 pixel wide version. And again, just by putting the URL patterns matching the syntax documented by your image CDN, like in this case, this is a syntax I think that Cloudinary uses, just simplified. You can get the 2000 pixel and the 500 pixel versions of your images right there on the fly. If you come up with some testing and realize that 560 and 1800 pixels are better numbers, you just change the template, whatever is generating this image tag for you, and deploy that. And again, Cloudinary will just provide the right size image when a user needs it. And then we're going to, of course, include an alt so the users know what's going on, even if they can't see the image. And we're going to use a lazy loading attribute as well so that this image doesn't block more important things from loading higher up the page. A question people sometimes ask is, wait a second, if I go to this whole CDN thing and I request a modified version of the image, isn't like their server doing a conversion or a resize process like on the fly? And if you uploaded some like giant like metapixel, terapixel, some huge nonsense giant image, and you're trying to get it resized like 300 pixels wide, isn't that really expensive? And isn't that slower than if I just resized everything like as part of my build process? And the answer is yes and no. The CDN doesn't actually do that conversion process every single request. Okay, they have pretty aggressive caching techniques, and you'll find, depending on what CDN you and your team research and want to use, you'll find them documenting how often they refresh the cache, how often they render the images, and also instructions they should have for how to prime the cache or how to get these images generated ahead of time before a real user happens to be the first person to load a given page, and they have to wait for a surfer operation. But that particular size would be then cached for everybody else, of course. And then the worst case scenario is if you have like a broken link checker that you run on your site on an automated way, that can prime the cache for you by triggering all those requests as it scrapes every page. So this is kind of like gluing it all together. How would you use a CDN like Cloudinary and responsive image syntaxes and modern formats like AVIF, and all glued together would be this slide. And of course, I would absolutely recommend that whatever tools you're using to build your site, come up with a component for this so that you can feed the component like just the image ID from the CDN, and it just builds everything else. So yeah, I'll pause for just a second. And while I do, I think Bishop's question about how these recommendations would work with a server-side rendering framework like Next.js. And this is one of the things where I unfortunately have to say I don't have enough Next experience to answer that one directly. What I like about like hybrid, there's server-side rendering with Next. I know you can set it up to generate a static file for every page, in which case it essentially functions like a fancy Reactified Jekyll. It's a static site generator and one configuration. But you can also configure it to load a JavaScript bundle lazily. I'm not sure if they default to async or defer for that, but essentially that takes over after you load the static page, and then all your other page renders can be configured to be handled by React running client side, so that the app or the site you've built starts behaving like a single page application where all the work is being done client side. So for those of you who aren't familiar with Next, that's a quick explanation of what you can do with it. Next generally pairs with React. There are comparable bundles like Nuxt that run on Vue templating, that kind of thing. But yeah, I would continue to, I would dig into optimization and research web performance for Next. I know that having it set up to generate a static version of every page as completely rendered as possible is an awesome way to go, but Next is a thing I haven't had an opportunity to use yet. And so I also would love to learn the answer to your question there, Bishop, too. But great question. Thanks for that. So we covered JavaScript, we've covered images. Those are kind of the two of the most bang for your buck optimization targets. Fonts are next. Every designer loves web fonts. Nobody wants to ever load defaults. Nobody really wants Palatino either, other than like strip mall signs on small buildings like various and sundry restaurants seem to be the worst offenders on Papyrus. But anyway, I'm not here to talk about Papyrus. I am going to talk about how to optimize the fonts you use. I'm going to jump into the deep end first here. And this may not be the first approach you take, but it's worth being mindful of. And that is by subsetting the font. What subsetting does is a tool like Glyphhanger, the one I've linked here, which runs on the back of a Python font management library that you'll have to install. Sorry, it's a bit of a step, but it's worth it. What Glyphhanger or similar tools do is they compare your font file and all the characters that have font images defined with a particular, that's what I'm looking for, metric or named range or series of characters it needs. So with subsetting, you can remove any characters that you're not actually using in your site from the font. A great use case would be some fonts have really, really large file sizes because they include Latin characters, the things that feed into English and French and Spanish and these things. Cyrillic characters, scripts more like Greek, Russian, those character shapes. They may even, in the same font, they're not usually, they usually go for a separate font. For CJK, which is Chinese, Japanese, and Korean characters. Lot to worry about when you get into like fonts in the deep end. But essentially, it takes a file, and if you're saying, for example, I'm writing or publishing a blog, or I'm building a web app that currently is only available in English. We aren't using accented or other modified characters from Spanish. We don't have the ñ to worry about. We're not writing in French, so we don't have the C with a little curl underneath it. I'm sorry, I don't know the name of that character. That'd be a fun thing for me to learn later. We're not using any of those extra characters, but they're all there in the font. As well as a whole bunch of like Unicode things that we're not using, like arrows and boxes and other drawing shapes. So I really just want English language characters, maybe English extended. That's actually a subset you can target, and numbers. But I don't want all like the drawing things or the wingding looking stuff. And Glyphhanger will actually go through your file based on the parameters you send it for which characters you want, and it will remove any character from the font file that's not on that list. And so your font file ends up dropping 20 to 30%, depending on what you do. If you're using a tool online like Typekit, you can use Typekit settings as you build a bundle or a kit to subset your languages that you need from that font file and not download the entirety of all of the characters imaginable in the broadest use case for that font. So great way to trim your files and make it even smaller. If you're building like really static things, like a static single page site, you can even run Glyphhanger to get the HTML content of the rendered page and just trim it to exactly those characters, get really, really narrow, which actually might be a handy technique if you're subsetting for like headlines in a custom font and you really want to streamline that. But font loading is another way we can win some performance points. First off, choose the right format. WAF and WAF2 are all you need. I'm serious. Like I was surprised to find this out 3 or 4 years ago. For years now, WAF, and now WAF2 is better compressed, have been all we've needed to handle all the major browsers, anything from IE 11 and up. If you need to go farther back in IE, add a TTF. There's really no reason to use EOT or SVG formatted fonts, although Font Squirrel and other like web font generation tools will give you all of those. I'm serious though, like WAF or WAF2 and TTF maybe are all you need to serve web fonts to modern browsers. It's rare to have a browser support requirement that needs older versions than that. And here's the other fun part. Nothing will break if you display the page in an older font, for example, because a user in IE11 can't get a WAF2 file. I would advocate for you working to convince your design and product teams, stakeholders, that it is not a bug for IE11 to get fallback fonts, or older browsers especially. But if you're still supporting IE11 to a degree, web fonts are like the least problematic thing. In fact, IE11 will have a faster experience than everybody else because they're not loading font files, right? So anyway, loading, choose the right formats, WAF2 if you can, or WAF are all you need pretty much. Font display swap is a great default, although you should do some research and look at the other font display options. Sometimes font display fallback is more useful than the default font display. Whenever possible, self-host your own fonts. And I say this primarily with reference to Google Web Fonts. For a long time, Google was saying things like, oh, but if you use Google Web Fonts and we're hosting them, then like every time users use Open Sans, like they've already got it cached in their browser because they saw Open Sans on these two other sites earlier in the month. And it's great because it's already cached and they're not having to download as much. And it turns out that that's a giant lie nowadays. It might have been true years ago, but if you find anybody still making that argument about font files, it's wrong. Safari and even Chrome block cross-domain cache reuse because they don't want that to be an attack or a privacy failure vector. There is an awesome web font library, and I meant to link it here. I'm going to update the slide deck tomorrow or over the weekend at some point soon to include a link, but there's a really cool tool deployed to Heroku. I remember that's part of the domain called Google Web Fonts Helper. And essentially what you do is you can search for any font files in Google, in the Google repo or Web Fonts library, and it gives you a zip file that you can then use to self-host. Self-hosting tends to be way faster than relying on Typekit, Cloud.typography, fonts.com, Google, or any of like the web font service companies. Yes, it's way easier to throw a Google Fonts link into your head and call it a day. And that may be great for like MVP or early releases, but when you start optimizing, self-hosting is going to be a big performance win for you. And then this link here is Zach Leatherman's comprehensive guide. It's everything you need to know about font loading, and it is 110% worth a bookmark, something to refer back to whenever you're working on loading fonts. JavaScript upgrades, CSS techniques, he's got it all. In fact, the Glyphanger library I linked to on the previous slide is a part of Zach's GitHub repo library. So those are fonts. I'm going to pause for just a second before moving into CSS, but again, I will come back and grab any font questions near the end if I don't pause long enough for the YouTube delay to catch up for everyone else. Alrighty, moving on to style sheets. How can we optimize our CSS? First off, by improving file size. We should be minifying our CSS. If you're using Sass or a preprocessor like that, strong likelihood, Sass definitely has this. I used Sass for years, still use it when I can, but it has a minification option in the build configuration. When you're building for production, you can tell Sass to give you the compressed output, and it shrinks all the white space and makes everything one-liner and makes it all nice and small. There are also some like optimizations you can make for even more tiny gains in your CSS. For example, if you're writing 0px all over the place, you might not need the unit pixels. A regular old 0 might be awesome wherever you're using that. There are a couple places where you can't get away with a regular 0. You need the unit, but for the most part, it can be optimized. You can change RGB formats to hex and save characters. And you think, whoa, should I be doing this all by hand? And the answer is, please no, that's a headache. And in terms of that much dev involvement for the performance win you're going to get, that is not a big win. That is a very costly win. So use some tools that automate it for you. I love PostCSS. It's a great little tool. Auto prefixer, if you're using auto prefixer already, you've got PostCSS in your build flow right now. Auto prefixer not only generates all the prefixes you need for any browser support you're looking for with regard to the more experimental or still vendor prefixed properties or selectors, auto prefixer also cleans up your CSS. So if you've used, like, for example, I remember the deal back in the day was to use Compass with Sass, or once Compass being Ruby based kind of fell out of favor and everybody's using Sass and a JavaScript build tool, Bourbon by Thoughtbot kind of took over these mix-in libraries for Sass that would generate all the prefixes for you. And you can do some mix and configuration and just get the prefixes you want mostly. But if you've got all of that, and maybe you've got a build tool or a file that hasn't been updated for years in terms of browser support responsiveness, you can use auto prefixer. And what it will do is it will delete all the prefixes you didn't need based on your browser's list configuration. So auto prefixer is fantastic. And for those tiny weird like micro modifications and optimizations, like fixing color formats for whatever is a shorter character count, dropping unnecessary pixel units where that happens to be the case. CSS Nano is a PostCSS plugin that's awesome for that. And you might be thinking, oh, but my team and I, we really use Sass. And I heard like Sass and PostCSS are mortal enemies locked in eternal combat. And that's simply not true. In fact, if you look on my Twitter or my webpage, jdsteinbach.com/talks, I did a talk a few years ago at Cascadia JS out in Washington about using Sass and PostCSS together. And they actually make a really great team and an awesome little 1-2 punch to solve the problem where Sass takes all of your Sass things like mix-ins and Sass variables, which are awesome and I like using, and turns it into great CSS. And then CSS Nano makes that CSS even better, more optimized, better organized, etc. So yeah, you can slap PostCSS on after Sass or less or another preprocessor. Another awesome technique to worry about is critical CSS. Critical is a funny word, so I put it in kind of quotes. What critical CSS is telling you to do, this technique says, isolate enough CSS to style like the top of your page above the fold. And again, I asterisked it because there is no fold. Every browser, every device, there are almost as many folds as there are visitors to your site. So the fold is a myth. There is no the fold. There are bajillions of folds. That I counted. There are literally bajillions. But what critical CSS says to do is isolate just enough CSS to get a nice styling on what happens above the fold, and actually directly inline that right into your HTML head. Put a style tag in there and put that CSS right in your markup, then lazy load the rest of the CSS. And here's a little code block that shows how you can lazy load a style sheet. Even if you're not using critical CSS, even if you've got CSS that just doesn't apply to the top of the page and you've split it for that case, here's how you handle lazy loading CSS. Set the media to print, which will be false in a browser. The media there would equal screen, or it would match all. But then onload, when the load event is done for the style sheet, then change its media to media all. And doing this will make sure the style sheet doesn't block rendering and actually works like a lazy loaded file. And your mileage may vary with this. There are browser tools and like Gulp Grunt plugins and Webpack things that can handle some critical CSSing for you. In my experimentation with it, I have not found, maybe I just tried it on sites where my headers were too complicated. The critical stuff just caused a lot of jostling and jumping, and it wasn't great. Your mileage may vary. If you're writing CSS really performantly in the first place, great. And if, of course, you're in a JavaScript context where all your CSS is written in your JavaScript bundle, I'm going to shudder about that for just a second, and then I'm going to calm down. Then, yeah, this critical technique wouldn't really work as well in the CSS in JS because all of your CSS is in the bundle file. But I read an article just this week that said basically he had all the numbers to prove it, the developer and the author, and essentially the conclusion was if you can extract all your CSS to a static standard, old school, if you want to call it that, a normal CSS file, and load that with a link tag in your head, like extract, I think is a Webpack plugin that gets you there, instead of having all of your CSS written in a JavaScript file, it is always more performant and quicker to separate your CSS from your JavaScript. So if any CSS questions come in the next few seconds here, as I wait for the stream to catch up with my life, I will answer them. Otherwise, we'll move on to a little bit of HTML conversation. Optimizing your CSS is useful, but it's not as big a win, generally speaking. It's not going to be the same measurably, like file size measurable win that optimizing your JavaScript and your images will probably be. But it's still worth doing as you have time because it will make a difference. So with regards to HTML, just a couple things. First off, minify your files. If you got a build tool, super. Always minify things for the server. Get rid of all the white space that isn't needed in your HTML and just kind of one-liner it. And then use the preload and prefetch attributes as necessary. These are worth some research. They send two different signals, but essentially they send signals to your browser to either resolve domains or start loading files ahead of time, or even entire URLs, so that you can kind of prime up or warm the cache up a little bit. It's not really a cache yet. You're just kind of preloading some resources on the one hand, or just prioritizing resources in the current load with prefetch. And you can kind of give the browser some hints to start downloading things ahead of time based on what a user is likely to go to or visit next in your site, or what resources you need to prioritize on your own site. This is generally a great idea, prefetch, with regard to assets loaded from a different domain. So if you are pulling in Google's fonts or typekit URLs, something like that, prefetch to resolve those domains ahead of time will optimize those loads so your fonts are sped up and moved up in the priority list to block or to stop layout shift and rendering jumps. What about the server? How can we optimize? I told you I wasn't going to talk much about the server, but I'm going to say one thing, and that is make sure compression is turned on your server. gzip and Brotli are two of the most common versions, and you just, if you're not the server admin, then find your team's server admin. And if it's possible for you to edit these things or set up these settings in your server with your team, or with a settings page if you're deploying to like a hosted service, like a kind of thing like Netlify, just ensure that compression is on. And what compression essentially does is it's like zipping a file to send it to somebody via email, and then they'll unzip it on their side. You might have like a 300 meg file, you zip it up, it's only 280, and you send it off via email, and they unzip it, and it's back to 300. That's what happens. You can take and compress a file, and maybe your style sheet was like 130 kilobytes. It compresses down to 70 or so. The browser only has to download 70K, and then the browser knows how to undo all the compression, and now it's back to its normal size. Really fun fact, gzip is really effective. A couple of years ago, I was working on a project where the client had provided some Sass mix-ins that they had written for other teams in their company, other departments to use, and that's what we were using, and ended up with a Sass update, fixed a bug. The bug happened to be preventing a not quite infinite, but in our case, recursive like 15, 16 times loop. And so as soon as we updated Sass, and the Sass bug that happened to be accidentally preventing recursion in the mixin library was out of the way, our CSS file blossomed to, if I recall correctly, it was 33 megabytes. That's huge. That's not acceptable for any CSS. But we didn't notice it on the load time because gzipping was enabled, and there's so much repetition in that loop, and gzip thrives in repetitious code. That's what it compresses, anything repetitious. That before we updated Sass, we were compressing with gzip down to like 15 or 16K, and afterwards it was only 17 or 18K. Our total file size, because of the way compression worked, didn't go up that much. So we literally sent a 33 megabyte style sheet over the wire under like 50K to give a really broad range. And then, of course, once it expanded, if you tried to view source and look at that file in your browser, you crashed your browser every time because browsers aren't written for 30 megabyte style sheets. But yeah, compression is fantastic. So that's my only advice, but it's a huge win. Make sure gzip or Brotli, whatever your team wants to go with, makes more sense for your team, your work. Make sure that's enabled on your server, because then everybody else gets the same files for fewer bytes. Oh, look at that. I had a slide where you could have looked at more words while I said all the other words. So yeah, here's a list of resources, a bunch of great stuff here that will further your research and push you off into bigger and better success with web performance. Thanks so much for coming, for listening. Now is your last chance to throw questions into the chat while I do my little thank you routine. Again, I'm James Steinbach. I'm a senior engineer at Auth0. If you are awesome at JavaScript, DM me. We have a position open on my team for a full stack JavaScript engineer, and by full stack we do mean Node and React a little bit, mostly Node. But yeah, if you are great at JavaScript and looking for a new thing, we are looking to hire somebody. So hit me up, JD Steinbach on all the places, Twitter, GitHub, my blog. So yeah, send me a message if that's interesting to you, and I will get you a link to the application with a referral. That'll bump you up the queue a little bit, which is great. But yeah, I am looking at the chat now, and this is a part where I just kind of make small talk for a minute and just confirm that nobody else has a question. Our next meetup, while I'm doing the small talky part, I like to make it relevant, will be the first week of October, provided we are able to schedule a speaker for then. So again, quick shout out to you all. If you have talks you'd like to give, or somebody who's given a talk recently that was brilliant, and you want to send Jason or me a message through Meetup, or ideally through the Front Range front end website, then that'd be great. Let us know, make an introduction, and we would love to continue with a few talks about performance, maybe diving into some more deeper end stuff, but also we're open to any talk that's relevant to front end, accessibility, even UX design, styles, browser improvements, all that great stuff. So again, yeah, we're going to wrap it up here. Thanks so much to everybody who was able to attend. We hope to see you next month, and take care. Have a great evening.